Hi, so I want to do a really quick thing with regard to Chomsky normal form. And it's a very interesting thought, and I want you to actually really think about this. So these are the typical 5 steps in order to convert a grammar into Chomsky normal form. You start with making sure that start variable is not on the right-hand side of any rule. You eliminate epsilon rules, not literally eliminate, but you just simulate with other rules. Then we eliminate unit rules. Then we make sure the right-hand side has only variables or a single terminal, and then we break up the long right-hand sides. So I want to focus with this particular conversion on this particular rule. Let's say A goes to a bunch of B's, variables with B's, and then a bunch of C's. And let's say that B and C are both nullable. So remember, nullable means that it can make the empty string. So in the step 2 here, what we would do is we would look at this and say, okay, we have a bunch of B's. Any one of them can be made into the empty string. In all the C's, we can make any one of those turn into the empty string. So let's say that there are K of these in total. Then what will happen after step 2 is that A is going to have 2 to the K different rules corresponding to it. Because any one of, actually is, I should say order 2 to the K, but it's exponential in the length of this right-hand side. So actually the stated way of doing this is not polytime conversion because of this particular mishap that might happen. So I want you to think about, in general, we can't reorder these rules. We can't have them be in a certain order. But it turns out that there is at least one different way of doing this, different ordering that is allowable, and we get that this is a polytime conversion. And it's moving step 5 between step 1 and 2. Think about it. If we break up the long right-hand sides, then none of these 3 is going to make any long right-hand side, so we don't have to revisit it again. And it's actually not a big deal even if we did, but we don't here. So then when we break up the long right-hand sides, the longest possible right-hand side is of length 2. And what happens then is that when we eliminate these epsilon rules, K is at most 2. And so when we do this step to eliminate epsilon rules, then we're going to only have A make at most, let's say, 4 different rules according to this rule right here. So we only get a constant size blow up of the context-free grammar in terms of the one before it. Whereas if we had it in this order with the 5 down here, then we will get exponential size blow up, which is actually pretty interesting. And it always works. We never have to visit this rule again because we never make long right-hand sides again, which is pretty cool. So hopefully that was interesting. Leave thoughts about this different ordering of the CNF algorithm in the comments down below. As always, please like the video and subscribe to the channel. It really helps us out. There are many other links in the video description if you want to support the channel further. And as always, thanks for watching, and I'll see you next time.